I'm going to look a bit more about the scientific method. So you should be able to use the scientific method. After all, you're supposed to be scientists. If you've done the BMS pathways, then you might have had an introduction to some of these ideas in critical skills. Otherwise, on the other pathways, you will have seen this in science, history and philosophy. So modern science is based on the idea of experience and empiricism, which was created by thinkers such as Francis Bacon, Locke, Hume and Leibniz. Bacon was one of the first ones, and he rejected the prevailing thing at the time was that you had to listen to the experts. All knowledge was already defined, and it was defined by the Greeks, and therefore you couldn't go beyond this by your own experience. And his argument against this was, we live nearly 2,000 years after the Greeks, therefore we've got 2,000 years more experience than they have, therefore our ideas are better than theirs were, which was a really good idea. So Bacon was the first person who rejected what's called medieval scholasticism and replaced it with let's go and do some experiments. He also supposedly invented the frozen chicken and died while doing it. So he got a dead chicken, and he stuffed snow in it to show that it could be frozen, but he caught a chill and died. Remember about chills and cold. We'll come back to that as an idea and question later. So what we have is established frameworks into which new ideas are placed. These are paradigms that I mentioned before. When we change the paradigms, these are called paradigm shifts. So originally we used to think that the world was the Earth was the centre of the universe and everything rotated around it. Now we know things are different. We used to know that Newtonian mechanics worked, then we ended up with special cases, which is relativity. Most of the time, we construct models in a very localized and small-scale way, based on some kind of anecdote. They're a limited application just to a small amount of the world around us. An example of this we'll come to is Ignaz Semmelweis and Cockbed fever. We don't start by creating a general law that applies to the entire universe. The only kind of people that do that are some parts of physics, such as cosmology, and mathematicians. So that's what mathematicians want to do. They want to discover something fundamentally beautiful that applies in an abstract way to everything you can possibly consider. In biology, it's a mess. It's very messy. Biology is nowhere near as simple as the other sciences. So you have to restrict your hypotheses and the things that you want to test to a very specified subset. So what you do is you take your theoretical framework and it creates some kind of model and hypothesis. Then you test this against observations and experiments. Now, there's concepts, ideas and techniques feed into how you construct a model. Now this might be mathematical techniques or experimental techniques, or a new machine that's been invented. These change the way that we can understand the world around us. Until we invented microscopes, we couldn't tell anything about microscopic living things. So the concept and idea of something microscopic that we can't see that is doing something just didn't exist. And it's unfair of us to imagine that the people before we had microscopes and understood there was a microbial world could imagine that causes of diseases could be microbes. They just had no chance because that wasn't part of their mental ability to construct a model. So where do models come from? They come from often analogy with other ideas. People think of electricity like water flowing down a stream. Pattern recognition. Humans like to see patterns in things. We create models because if we see something behaving in a regular way, we anticipate that that's going to happen always. So the sun comes up, we have a new day. We know that during the year the temperature rises and then it goes down and we get darker nights and we get sunnier days during the summer and darker nights in the winter. So we created the seasons by recognizing patterns, that the trees lose their leaves, that they regrow their leaves. All of these are patterns we can see. Invention, as I said, of new tools helps you to discover new aspects of the world. Microscope was very important, the telescope, now all of the imaging and the scan equipment that we use, magnetic resonance, is the important thing that's coming in now. And also development of mathematical methods. Until people invented zero, which oddly took quite a long time to invent, and equals is only 400 years old. Up until the 1600s, people didn't have an equal sign, so people couldn't do equations because nothing equated. Also, you have people who have intuition and imagination. That's why reading a lot is very important. So for example, one of the physicists, Richard Feynman, he was trying to understand how subatomic particles worked, and he saw somebody drop a plate on the floor, and it does that spinning before it comes to rest when it bounces off the floor. And then he understood that if he added spin to his model, then it explained how the subatomic particles were working. Now, science is not completely objective, regardless of most scientists claiming that it is, and most people wanting it to be. It depends on your context. As I said, before they discovered microbes, there was no way they could invent a theory that explained diseases which were results of microbial disease. They explained it in terms of what are called the humours, balances of different fluids within the body. Now we have the living things as computers analogy for brain function particularly. But we can only do that because we've invented computers. Before that, the most complicated technical thing that everybody could see in their everyday life was a watch. So people used to imagine that living organisms were like clockwork organisms. So you see that science changes dependent on the experiences that we have and the way we can tell our stories. Now, to be good science, something has to be testable, it has to be able to be extended to new areas, it must fit with existing observations, and most importantly, it must allow new predictions. It must allow you to predict something for the future or some previously unknown case. So here I mentioned Bode's law. So Bode created a law which described how the planets rotated around the sun, but he used the movement of every single one of the planets to build his law. He couldn't predict anything new, and when we found a new planet after that, which was more distant with telescope, Bode's law failed to work because it couldn't predict new cases. Your science fails if it becomes so specific that it only applies to the single experiment you've carried out and cannot be applied to any one